It was good. Today we're talking about gases in chemistry. So, what are the three qualities of gas molecules? One is that they have lots of space in between molecules. Second is that they exert negligible forces between each other, and three, they are free flow in and at random motion. The motion that they're in, random and constant speed, like they're at random motion and they're at a constant speed. Three properties that affect gas behavior is temperature, volume, and pressure. So the temperature relation of temperature to kinetic energy to collisions. So when you increase temperature, you increase kinetic energy, and that'll increase the number of collisions you have. So now the relation of gas to volume. If you have lower volume, you're gonna have more collisions. You're gonna have more higher pressure because the gas molecules will be hitting around the surface or the surface of the container much more. Pressure related to area. Wait, what does that mean? Wait, what? Well, if you, okay, because force equals, wait, no, is pressure equal to mass divided by area? So if you have a smaller area, you're gonna have larger pressure, right? That makes sense. Let me see this. Pressure equals force divided by area. So yeah, if you have a lower area, you're gonna have higher pressure. Gas volume inversely affects pressure. What does that mean? Yeah, that just means if you have lower volume, you're gonna have higher pressure. So I think I kind of explained everything there. Okay, Boyle's law. Okay, wait, let me just block these so I remember. Okay, Boyle's law is P1V1 equals P2V2. So pressure and volume are inversely proportional. Charles' law is temperature is inversely proportional to volume. So if you have higher temperature, you're gonna have lower volume. Wait, how does that make sense? No. V and T they are directly proportional, right? Yeah, because P1 V1. So higher pressure equals lower volume. So lower volume equals higher pressure. That's inversely proportional. Charles' law is that volume and temperature are proportional. So having a higher temperature, you'll have a higher volume. Then Avogadro's is, it has moles in it. It's NV, ANV. Yeah, so volume is directly proportional, like moles is directly proportional to volume. If you have more moles of a substance, you can have higher volume. Gay-Lussac is, so sorry, like, do we need to know each specific, like, I know how to derive each one, but it's just like, do we need to know which specific one? It's pressure for sure. Pressure and temperature. So if you have, these are inversely proportional ones. Oh no, these are directly proportional ones. Wait, P over T, so P1 T1 equals T2 P2. So it's higher temperature, higher pressure. That makes sense. Okay. Ideal gas law, 5 points. So what are the 5 points? The force exerted is minimal between the two. Ideal gas law. Ideal gas law, 5 points. Bro, I just gotta think, bro. Just allow, bro. Just allow. Why is someone biking outside and it's raining, bro? Can I try to do a wheelie? Anyways, 5 points. Bro, I literally should know this one. I just need to think about it. So one of them is the forces between them are negligible. Like, we're gonna ignore the fact that there are intermolecular forces. Second is No, I don't remember that. What are the five? Okay, well, anyways, I could tell you when will a gas behave most ideally when high temperature, low pressure. Low pressure means that there's lots of space for the gas molecules to move around, then they won't have intermolecular forces. High temperature means that they're bouncing up, they're having elastic conditions. What is STP? STP is 1 atm at 273.15 Kelvin. The volume of 1 mole of gas at STP will be 22.4 liters. Gas density formula, I'm not looking, it's density is equal to PM over RT, or it's just equal to mass over volume. What is diffusion and effusion? Diffusion is the movement of gas from high concentration to low concentration, or like high pressure areas to low pressure areas. Effusion is just moving like out of a single hole. And what effuses faster? It'll be the gas or anything, the gas with the lower molar mass, or anything with the lower molar mass, because it's more free floating, so it'll be able to dip. Graham's law of effusion, it's like K2 or R2 over R1 is equal to square root of M1 over M2, M being the molar mass. Oh wait, it's the other way. Whoops. I feel like you could work the other way too though. If you just flip the two values. R1 over R2. Yeah, it should work the other way. As long as you remember to keep them opposite to each other. I think. Because you're never going to know which one's R1 and which one's R2. It just depends on what you're getting asked in the question. Okay, so the 5 postulates of the ideal gas law are: gas particles are constant, random, straight line motion. Gas particles are point masses with negligible volume, so they have no volume. Point 3, there's no intermolecular forces. 4, they are perfectly elastic collisions. 5, average kinetic energy of gas particles is directly proportional to the absolute temperature. Okay, so let me say that again. So the average the temperature, or the kinetic energy, or the average kinetic energy of all the particles, which is temperature, is equal to the or is directly proportional to the absolute temperature, which is Kelvin. Okay, that's 1. Number 2, the volume is negligible. Number 3, the collisions are perfectly elastic. Number 4, they are in random, constant, straight line motion. And number 5, rule number 5, keep it. Yeah, wait. Wait, did I say negligible or negligible? It's negligible. Negligible means it is not negligible, and that means it's important. So that's wrong. Okay, let me just restart. So one of them is, so 5 postulates of ideal gas law. 1, the gas particles are in random, constant, straight line motion. Number 2, the average kinetic energy of all the particles is equal or directly proportional to the temperature, the absolute temperature in Kelvin. Number 3, wait, what? Let me think. The volume is negligible. Number 4, there's no intermolecular forces between the particles. And 5, they go through perfectly elastic collisions. Okay, that's all for today. Goodbye.